A Map of the Invisible by Jon Butterworth. Read by Wayne Forrester. Prologue. The journey begins. Consider a thought experiment. Take an apple and cut it in half. Then cut it in half again, and keep doing that. What will you end up with? Or, less destructively, peer more and more closely into an apple. What structure is revealed? Is everything made up of a small set of common constituents, call them elements or atoms, arranged in various different ways? If so, what happens if I look more closely at those constituents? Are they made of something even smaller? What is eventually revealed is a landscape inhabited by strange and wonderful particles. In this landscape are islands of complexity, linked by networks of communication, emerging from the oceans of our ignorance. The landscape starts from everyday life, with an apple, for example, and extends to the wild frontier of the almost impossibly small. To get from an apple to the impossibly small, we will need to set sail. We will need a boat, a craft which will stand for the microscopes, accelerators and other machinery that extend our vision beyond the capacity of the naked eye and into the heart of the atom and beyond. How far can we sail? Is there an end to this invisible world? Are there indivisible particles, of which everything else is made? Or can we carry on forever, finding ever smaller stuff, sailing ever further eastwards? These questions have been discussed for millennia, and addressing them is one of the goals of physics. The answers, as far as we know them, are found in the strange, invisible landscape that we will explore and map in this book. The name of the game. The science of the very smallest things is commonly called particle physics. No name is perfect, and this one is confusing in a number of ways. The word particle is potentially misleading. Physicists study particles of sand, pollutants, dust, in space and in the atmosphere, and other small clumps of stuff which have nothing directly to do with the ultimate constituents of matter. Sometimes particle physics is called elementary particle physics, to distinguish it from the study of these composite particles. But this isn't much help, since protons and neutrons, important tiny particles which are crucial features in the landscape of the subject, aren't elementary. At some point, we may even find out that the fundamental particles of our current theories aren't elementary either, although studying them is definitely particle physics. Elementary particle physics is also disfavored as a term for research groups or university courses because it makes the subject sound too easy. A student who enrolled on an elementary particle physics course might get a shock when confronted with the equations relating to the particles we will be searching for. High-energy physics is a commonly used alternative, and it is true that the direct approach to particle physics, basically smashing things together in huge colliders to see what happens, involves a lot of energy. But some of the key experiments actually rely on hunting for very, very rare, very low-energy particles. Physicists hide their detectors deep underground to try to evade tiny amounts of noise, and every ultra-low energy jitter is a cause for annoyance or excitement. Indirectly, these experiments do tell us something about what goes on at high energies, but calling them high-energy physics somehow seems a bit inappropriate. Another problem with high-energy physics, as a name, is that nuclear physicists, astrophysicists, plasma physicists, and many more all deal with energies that are much higher than those used to probe the limits of particle physics. The energy of a collision in the Large Hadron Collider, which, at the time of writing, is the highest energy particle collider ever built, is tiny compared to the energy that is released in a functioning
Sample complete. Ready to continue?